Okay, let's talk about finding the distance using the Pythagorean theorem. So let's just kind of refresh what we talked about before. So remember that if it's a vertical or horizontal line, we're just going to count it. So remember, we just either count the vertical line up and down, and we count the spaces on the horizontal left and right, and we can find the distance that way. But then it's what happens when the line is diagonal and you actually can't count the spaces. Well, one of the methods that we're going to talk about in this video is going to use the Pythagorean theorem. Well, what is the Pythagorean theorem? So let's kind of go over that. So remember, you can use the Pythagorean theorem when you have a right triangle. And when you have the right triangle, the Pythagorean theorem helps you find lengths of one of the missing sides. And for what we're going to do right now, we're going to be using it to find the hypotenuse. And we'll get more to that. The Pythagorean theorem is the a squared plus b squared equals c squared. And remember, this formula will always be on your formula sheet. So again, the hypotenuse is going to be the side that's across from the right angle. So remember, a right triangle has to have a right angle, and it's the side that's across from it, which is the longest side of the triangle. Okay, and then the other two sides are what we call legs, and those are A and B, and it doesn't matter which one is A and which one is B. Okay, so let's just practice just a generic problem being able to find the hypotenuse, find the value of x when I'm given the other two sides, and we know that this has to be, we can use Pythagorean theorem because we have a right triangle. So remember, the hypotenuse, the side across from the right triangle, always has to go in for c. So remember that Pythagorean theorem is a squared plus b squared equals c squared. And so we're going to go ahead and plug in. So we have 8 squared plus 13 squared equals x squared. And so we're just going to go ahead and solve that. And so we can keep working this out. So 8 squared is 64 plus 13 squared is 169 equals x squared. And now we're going to add those up. So we're going to add up 64 and 169, which you get 233. So 233 equals x squared. And remember, we don't want to know what x squared is. We want to know the value of x. So in order to undo squaring, we're going to square root both sides. So we're going to take the square root of both sides. And you can use Desmos for this. And so you put in the square root of 233, which you actually get a decimal, and that's okay. And let's round to the nearest hundredths. So it's 15.26 is equal to x. So roughly, that is the length of x, which should make sense because the hypotenuse has to be the longest side, so that would be longer than the other two sides. Okay, so that's just a refresher of the Pythagorean theorem. Now, let's see how we use that to find distance. Okay, so to use the Pythagorean theorem to find distance, we have to first create a right triangle, because remember, we can't use Pythagorean theorem if we don't have a right triangle. So how are we going to do that? The first thing we're going to do is we're going to create a right triangle by drawing the vertical and the horizontal line. So I'm going to go ahead and start. So I'm going to go ahead and draw a vertical line. And what we're doing is we're trying to connect the endpoints. And please pretend my line was straight. Okay, I redid it. So we have our vertical line. And then I'm gonna use a different color, and I'm gonna do my horizontal line. So basically we're just connecting the endpoints to make a right triangle. So because of these, now we have a right triangle here. And then so step 2 says we need to find the length of the vertical and horizontal lines. Well, how do we find the length of vertical and horizontal lines? We just count them. So here we're gonna count the vertical, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has a length of 9. And then we're going to do the same for the horizontal line. We're going to count and find the distance. So 1, 2, 3, 4, 5, 6. So there we go. That one has 6. And because what we're really trying to find here is the length of this diagonal line, which we're going to call, I'm going to use a different color. We'll call that X. So now hopefully you can see that there is a right triangle here. And we're going to go ahead and plug that into the Pythagorean theorem. So remember, Pythagorean theorem was a squared plus b squared equals c squared. And so your A and your B are your vertical and horizontal distances. So we have a 9 squared plus 6 squared equals x squared, because we don't know what that diagonal piece is. And then we're just going to go ahead and work this out. So 9 squared is 81 plus 6 squared is 36 equals x squared. And so now we're just going to add these together. So we have 81 plus 36, which is 117 equals x squared. And again, remember, I don't want to know what x squared is. I want to know what x is. So in order to get rid of the square, we need to do the square root. Remember, those are inverse operations. So then we take the square root of 117. And remember, you can plug this into your Desmos calculator. And let's round to the nearest hundredth. So we got 10.82 equals x. So that means the length of that diagonal is about 10.82 units. All right, so we have two examples that we're going to find. So this one says, example 1, find the length of the segment. Remember, length and distance can be interchangeable. So we don't have a right triangle yet, so we have to make it. So we're going to do our vertical and horizontal lines. Now, in this case, it doesn't matter which side you do it on. Like I could go up here and over that way, or I can go down here and go this way. Doesn't matter which way your right triangle is formed. So I'm gonna go here, and again, we're gonna pretend that's a straight line. So there's our vertical, and let's do our horizontal line. Remember where our vertical and horizontal meet, that makes our right angle. All right, so let's go ahead and count our distance of our green line. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units long. And then our horizontal, we start from here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one's 9 units long. And we don't know the length of the diagonal because that's what we're looking for, because we want to know the length of that line. So we're going to go ahead and plug this into Pythagorean theorem of a squared plus b squared equals c squared. And let's plug in our value. So we got 8 squared plus 9 squared equals, oops, sorry, equals x squared. And let's work that out. So we get 64 plus 81 equals x squared. And then here we're just going to add everything up. So we do 64 plus 81, which is 145. So 145 equals x squared. And here, remember again, I don't want to know what x squared is. I want to know x. So we're going to take the square root of both sides. And then we can do the square root of 145. Again, use your Desmos calculator. Let's round to the nearest hundredth. So remember, that's two numbers after the decimal point. 12.04 is equal to x. So that means the length of that segment is 12.04 units. All right, example 2, we want to find the distance between these 2 points, point 25 and 4, -1. So if we look, these points are not on the graph, but that's okay. We're just going to go ahead and graph it. So remember, we're going to plot the point 25, which should be right here. And then we're going to plot the point 4, -1. So 4, -1. So right here. And then we're going to draw a line to connect. And so now once we have our line, kind of looks like example 1. So go ahead and pause the video, finish drawing in your right triangle, and determine the distance of this segment. So hopefully you've gotten your triangle drawn, and you see, even if your triangle's on the other side, you should still have a triangle that is 6 vertically and 2 units horizontally. Okay, and then so remember, you're just going to go ahead and plug that into the Pythagorean theorem, and you can go ahead and solve. So you can go ahead and pause and make sure you solve this. And then so we go ahead and solve, and you should end up with 6.32 units. Okay, and so remember, in order to find the distance of a diagonal line using the Pythagorean theorem, you just need to draw a horizontal and vertical line to make the right triangle, and then go ahead and find the lengths of those and then plug them into the Pythagorean theorem and solve for the missing value. All right, that's it.